EAP-TLS, Extensible Authentication Protocol Transport Layer Security, is a security protocol used in computer networks to establish secure and mutual authentication between a client device, such as a smartphone or a computer, and a network server like Wi-Fi access point or a VPN. It relies on a Transport Layer Security Protocol (TLS) to create a secure communications channel. In EAP-TLS, both the client and server present digital certificates to prove their identities. These certificates are issued by Trusted Certificate Authorities (CAs). The authentication process involves a cryptographic handshake, during which the client and server exchange encrypted data to ensure the authenticity of both parties. TLS is highly secure because it's based on public key encryption, making it extremely difficult for unauthorized users or devices to gain access to the network. It is commonly used in settings where network security and data privacy are of utmost importance, such as enterprise environments, secure Wi-Fi networks, and VPNs. EAP itself is not tied to a specific version of TLS. Instead, the version of TLS supported in EAP depends on the specific EAP method being used and the configuration of the network or system implementing EAP. EAP methods, including EAP-TLS, can support various versions of TLS. EAP-TLS, for example, typically uses TLS for securing the authentication process. The supported TLS versions may vary based on the implementation and configuration, but often supports the latest version of TLS for security reasons. EAP methods can accommodate different TLS versions, including TLS 1.2 and TLS 1.3. The choice of the TLS version should align with security best practices and the security policies of the network and organization using EAP for authentication. It's important to keep EAP methods and TLS versions up to date to ensure network security. The authentication process between a client and server using EAP, such as the case of EAP-TLS, involves several steps, including a cryptographic handshake to establish a secure connection. Step 1. The initiation. The client, which could be a device like a computer or a smartphone, initiates the connection to the network or server that requires authentication. The server, which could be a Wi-Fi access point, a VPN server, or any other network service, responds to the client initiation. The server presents its digital certificate to the client. The certificate is issued by a Trusted Certificate Authority (CA). The certificate contains the server's public key, allowing the client to verify the server's identity. It then responds by presenting its own digital certificate to the server. Like the server certificate, the client certificate contains the public key and is issued again by a trusted CA. This step ensures mutual authentication, meaning both the client and server prove their identities to each other. The client and server initiate a handshake, which establishes the secure connection. This handshake is usually based on the TLS protocol. During the handshake, the client and server agree on the cryptographic parameters, such as the encryption algorithm and the keys that will be used for the secure communication. Next, the key exchange. The handshake involves securely exchanging a session key that will be used to encrypt and decrypt data between the client and server. Public key cryptography is used for the key exchange, ensuring the confidentiality of the key even if intercepted. Now we've completed the authentication and session establishment. Once the handshake is successfully completed, both the client and server are assured of each other's authenticity. A secure session is established. All further communication between the client and server is encrypted and secure, protecting the data exchanged during the session. The security of EAP can vary significantly depending on the specific EAP method used and the underlying security measures, such as the type of certificates, keys, and encryption algorithms chosen. EAP is more of a framework that can support various authentication methods, and its secure level depends on the method and its configuration. TLS is considered one of the most secure EAP methods. It employs mutual authentication with digital certificates, making it highly resistant to attacks like man-in-the-middle. The security of EAP-TLS is on par with the security of TLS, which is widely used to secure web traffic. EAP-TLS, Tunneled TLS, and PEEP, Protected Extensible Authentication Protocol, provide strong security, and particularly when inner authentication methods like EAP-TLS and EAP-MS-CHAP version 2 are used within the TLS encrypted tunnel. However, they may be more vulnerable to certain attacks compared to EAP-TLS. EAP-MS-CHAP version 2, Microsoft Challenge Handshake Authentication Protocol version 2, while widely used, This method is less secure than EAP-TLS, as it relies on username password credentials for authentication. These credentials can be vulnerable to password guessing or credential theft. EAP-MD5, Message Digest 5, is one of the least secure EAP methods. It doesn't provide strong protection against eavesdropping, and the authentication process is not as robust as those based on digital certificates. In summary, the security of EAP depends on the specific EAP method chosen and how it's implemented. EAP-TLS, which uses digital certificates, is considered one of the most secure EAP methods. All methods that rely on weaker authentication mechanisms like passwords are less secure. It's crucial to select the appropriate EAP method based on the security requirements of the network or system, as well as to properly configure and maintain it to mitigate potential security risks.